In my previous video, I showed how to create a simple cannon in 3D using Unreal Engine primitives. In this video, I'll show you how to do something similar using Paper2D, which is Unreal Engine's 2D library. So the first thing I'm going to do is import an asset, and from the desktop, I'm going to grab these two things that I need. The first one is a sprite sheet with my cannon and my cannonball sprite, and the second one is my tile atlas, which we're not going to need just yet, but we will need later on to make a level. So I'm going to rename this to sheet, rename this one to T tile set, again T meaning texture, because right now they are just simple Unreal textures, but if I right click here, I can take a sprite action and extract sprites from here. This default extract mode of auto does exactly the right thing. Because I have the alpha channel set on that image, I carved out the sections that I didn't need in GIMP so that the sections that were not part of the sprite were alpha, and so this auto mode pulls up exactly what I want. Nice. So let's call this SP Cannon, SP for sprite. Let's call this SP Cannonball. And this is some extra little piece of cruft that seems to have picked up in that auto, so we'll just delete that. Perfect. All right, let's take a look at the cannon. So one thing we can see when we look at this cannon is that its pivot point, center, is right in the middle. And that's not actually where I want it, but we can change that. Let's see, pivot mode, custom, and I think around like 30 and 44 should be about right. Yeah, let's make it 34 and 42. Close enough. So that when I rotate it, it'll rotate around that point. That's the idea here. Another thing I'm going to do while I'm editing the sprite is I'm going to set up a socket, and I'll do that here. And we're going to call this socket mouth. It'll be the mouth of the cannon. I can select it and slide it over. So the idea here is that when I eventually am launching cannonballs out of this, they will appear at this position. And I can do that by accessing that socket via blueprints. Okay, so that sets up my cannon. The cannonball is probably okay the way it is. The first thing we want to do then in terms of the level is let's make a new pawn, which will be the cannon. I'll call this BP cannon. And this cannon will be the agent that is actually controlled by the player, the thing that does the shooting. And its scene is going to contain the cannon. So this is how we make a pawn that has a 2D sprite attached to it. And that should be fine for now. I should be able to take this and drop it into the world. And yeah, there it is. I'm actually going to eliminate the spawn point and the whole ground here. Good. Another thing we're going to need is a camera to look at our scene. I'm going to use a fixed camera. So here's our camera, and we need to, whoops, move that to where I want it. You know, life will be easier if I put this at the origin, and then I put the camera at the origin, and then I can do some fine tuning. So I'll pull the camera out this way and get it facing the way that I want. There. So now the camera is looking directly at the cannon, and I probably want the cannon off to the left of the screen, so we'll just kind of fudge it like this. There. That's good enough for our purposes, I think. If we go to play the game, we actually still have the default pawn behavior because we haven't changed the game mode, right? We can still fly around like this, and that's not what we want. So I'm going to make a new blueprint class for my game mode. I'll call it BP game mode. That will contain the rules of the game, the rules of the level. I'm going to make a blueprint class called BP player controller, and that'll be the agent that actually intercepts the keyboard input and then directs it into my controlled pawn. So in order to get all these pieces working together, we have to go into, oh, you know, one other piece to save me some effort. I'm going to do Control-Shift-S to save everything, and that'll force me to save my map. Okay, good. So over in Edit, Project Settings, Maps and Modes, here we can set the game mode to be BP game mode. So instead of using the default built-in kind of do-nothing game mode, this means it'll use our own one. And inside of our game mode, we can tell it the player controller we want is the BP player controller. And the last little piece of plumbing we have to do here is set up this pawn so that it is automatically possessed by the player controller. Of course, any of these steps we could do manually through other programming steps, but the IDE gives us convenient ways to do that. So this will be auto possess player 0. Good. So if I say play, I still have not actually told it to switch to that camera. So we can do that in a couple of ways. How about this time? Last time I showed how you could do it from within the map blueprint. This time let's do it from the player controller. So in the player controller, we can say as soon as the game is started. Oh, you know what? Now that I think about it, this is going to be an awkward way to get access to the camera. Let's just do it the other way. I'll select the camera and go to Blueprints, Open Level Blueprint. The reason why this is more convenient is I can simply right-click and get a reference to that camera actor. Whereas if I were to do it through the player controller, I would have to do some casting or dancing around to try to find it. The level knows exactly where this camera actor is. So when the game starts, what we want to do is set view target, uncheck context sensitivity to find the one that I want. That's it. This is the view target, and we need to get the player controller here. Which in a single player game, very simply, index 0 is always just the player. So that then should give us, a game looking at our cannon. Great, it's a good start. Okay, let's make this cannon so that we can rotate it. We'll go to Edit, Project Settings, and under Engine and Input, we can add an axis mapping, and let's call this the cannon incline or cannon angle. And we're going to use the keyboard. We'll take the up key to go up, and correspondingly the down key to go down. Good. And as long as we're in here, let's add the fire event as well to the spacebar. Great. That looks good. Now, back in our player controller, we can listen for those events. So we can say when we get the, what do we call it? Cannon angle axis event. We want to get the controlled pawn, and we want to get it as a BP cannon. So we're going to cast it to a BP cannon. And then we want to rotate it. So let's take this and say add rotation. Let's see, actor, world rotation. And what's the amount of rotation we want? Well, we can split this struct and take this value and plug it directly into y. So that would make it so that we're adding positive y when we go up and negative y when we go down. Beautiful. Our next step will be to actually make the cannon fire. So we need something for it to fire. So we'll make a new blueprint for the cannonball. And this will be simply an actor because it's not going to be possessed by the player. So BP cannonball. And just like the cannon, we can pop that open and we can take our sprite, attach it to the scene root, and there we go. We've got a cannonball. And if we want to see it, we can always grab this cannonball and drop it in the scene. And yep, there it is. One thing we know for sure about our cannonballs is that we want them to have physics enabled. So back over here, we can say turn on physics. And play again, and there it goes. It's affected by gravity. The convenience of having a powerful engine when you're launching little projectiles. Anyway, well, of course, we're not launching anything yet. Let's just get rid of that one, and we'll make it so that when we press spacebar, we spawn a projectile out in front of the cannon. So back over here, when we get the fire action, first thing we want to do is figure out where this should be spawned. Now remember, in the cannon, we set up this mouth socket. So let's figure out where that is in world coordinates. So first thing we want to do is get the controlled pawn. And from the controlled pawn, again, we're going to turn that into a BP cannon. Because it's the cannon that has the cannon sprite, and it's the cannon sprite that has the socket we want. So here we can get the socket. Let's see, get socket location, yep, out of the cannon sprite. It's got a little ugly. There we are. And the socket was called mouth. So this return value is the location of that socket in world coordinates, which means we can conveniently use it when we spawn actor from class, and the class will be cannonball. Once again, because this is a struct, I can right click on it and split it and say this is the location it should be at. Alright, let's try that. Neat. So a couple of things are happening here that we don't want. One is that the cannonball is immediately colliding with the cannon that's firing it. We don't want that, of course. Another thing is that the cannonball, even though we're using Paper2D, we're not locked into a single plane, so the collision is causing the cannonball to sort of fly toward the camera. We want to stop both of those things from happening. So the first thing we're going to do is handle the collision. And again, as in the last video, I think the easiest way to do that is just turn off collision on the cannon. So we'll say that the cannon, oh, I'm sorry, this is cannonball. I'm in the wrong place. The cannon, here's the cannonball. Sorry, the cannon. I should have named them something different. Collision presets, no collisions. So that fixes one problem. Right, no longer getting collision events. They're still kind of falling in a funny way. See, they're colliding with each other, which is what's making them fall in a funny way. So what I need to do is lock the cannonballs to a plane. So we can do that here again within a BP cannonball. In the physics area, we can set a constraint, which is to lock them to the XZ plane. So that means we're not going to allow anything to push them forward or backward along that y-axis. And that should give us the behavior we want. All right. Obviously, next step is to add some impulse. So let's go back to our player controller and say after we make this cannonball, we want to add an impulse to the cannonball. Not to self, though, to the one we just created. There we go, specifically to the cannonball part of the one we just created. And the next step we want is to get the rotation of the cannon so that we can create our impulse correctly. Let's make that vector. And I'll just take some default value here. And we want to get the rotation of the cannon. Let's see, we've got the cannon here. So we can say get the rotation, the world rotation of that cannon. And we want to rotate that vector, rotate that vector by that amount. So rotate vector by that rotation, take the result, that's our impulse. Okay, let's see what that looks like. Not much. You know, the default physics engine in Unreal is doing computation of velocity and momentum based on the interpreted mass of these different 3D objects. We can turn that off here for the sake of the impulse and make it just change the velocity instead of changing the real physical impulse, right? What would be done in, say, more proper physics simulation of a cannonball. What that gets me here in a very pragmatic sense is I can use smaller values because we're ignoring mass. So that's pretty neat. Let's add a little bit more. Say 1,000. Perfect. I think it's good for our demo purposes. All right, the next thing we need is a ground or a floor to have these things run into. So we can go back to our content browser. Remember, we imported this image is just a texture right now, right? Just an image, but we want to use Paper2D to make it into a proper tile set. So once again, convenient, create tile set, and we'll call this, oops, F2 to rename, TS tile set. Here. And so by default, it's using a 32 by 32 tile size, which means across this image it's trying to interpret these as different tiles. But really, I just have a single tile set. The image happens to be 90 by 90. So now it is reading this as being one single tile. Also, while I'm in here, I want to set up collision. And so I can say add a box. Notice that box is exactly the right size that we want. And down here under collision data, we set this as being tight bounding box. To verify that, I'll click on this colliding tiles view. Yeah, that's exactly what we want, is that the collision box exactly matches the tile itself. All right, so let's save that. Back over here, we can create a map out of this tile set. Now again, this is just a real quick and dirty example. You probably really want multiple tiles, but this is okay. So I'll call this TM simple map. And so this is a map like a world, like you might have in a 2D platform game made out of different tiles. In my case, I'll just make it maybe 20 wide, and it could actually just be 1 high because it's a very uninteresting map. I'll select the tile I want from my tile set and just paint it across here. You can imagine how you could add tiles with holes in them, some that have collision, some that don't. Right? Sky's the limit here. We're just trying to show some simple ideas. Save this. And that lets us then grab the map and just plop it directly into the world. Now, one thing to watch out for is these things are not coplanar. All right, so the cannon is going to create cannonballs, but the cannonballs would fall right in front of this map here. So what we can do, or what we need to do, is put that also at a y of 0. Now everything's coplanar, and so things should behave the way we expect, or the way we want. Let's try it. Not too shabby. Now you might notice something a little bit strange about how these are bouncing, and that's because by default each of these sprites has a square bounding box. So we can hop over here, let's see, where is it? SP Cannonball, and look at its collision. See, it has a square collision box, which isn't really what we want. Once again, the built-in tools here are quite nice. We can make this a shrink wrapped. And this will create a polygon that approximates the border of the shape. Every vertex in this polygon will have computational cost. And so if this is a really high fidelity polygon, then we're spending a lot of computational power to do collision on something that doesn't really matter. So this shrink wrap is really fine for us. You could go in and fine tune it, but we certainly don't need to for this purpose. Now we should see this look, yeah, see how they're hitting and rolling a little bit more? Because the collisions are being handled in a slightly nicer way. Great. So from here, well, the sky's the limit, right? You could add some obstacles, you could incorporate some realistic physics, you could add score for different purposes. The point of this video is just to show you some of the basic tools to enable you to get in and make something really neat. So I hope you enjoyed it. Happy programming.